In this video, I'll show you how to solve the ALEKS problem called predicting bond angles in molecules with one central atom and no octet rule exceptions. First thing that we're going to need to do is draw or come up with or look up the Lewis structure for the molecule in our problem, OCN-. I'm going to look this structure up. It is kind of a tricky Lewis structure. It's not too hard. It's definitely something that you could draw, but it's going to take a lot of time for me to draw this particular Lewis structure. So we're just going to go straight to the internet and look up OCN-. When you're doing this, double check because sometimes you can get some bad structures on here, but double check, make sure that it makes sense, that it has the right atoms, it has the right charge. I'm going to go with this structure right here because it looks pretty legit. What is the angle between the carbon-oxygen bond and the carbon-nitrogen bond? I'm going to copy this Lewis structure down so that we have this for reference. No need to draw the charge on there. So it's asking us in the question, what is this particular angle right there? And this one's actually pretty easy. It's 180 degrees. But for a trickier problem, what you want to do is consult a table of bond angles for different types of molecules. Bond angles are based on around the central atom, the number of bonds, in this case 2, and also the number of lone pairs, in this case 0. So you can find a data table that's going to give you all of the different possible combinations of bonds and lone pairs for a central atom, and it's also going to tell you what the bond angle is that corresponds to each one of these different combinations of bonds and lone pairs. So once you get your Lewis structure, count up how many bonds around the central atom, count up how many lone pairs around the central atom, or whatever atom it's referring you to, consult your table and see what that bond angle is.